Right now, there's an invisible race happening all around us. It's not on a track, and there are no checkered flags. It's a race for speed in conversation. We're talking about a battle over the last few crucial milliseconds that separate talking at an AI from truly, genuinely talking with one. Today, we're going to break down the incredible effort that goes into making AI conversation feel perfectly, and I mean flawlessly, human.
Come on, we've all been there, right? You call your bank or an airline and you get that pause, that super awkward, empty silence right after you finish talking. It makes you wonder, hello, are you still there? Did I get disconnected? It's that single moment of frustration that turns a helpful tool into a total roadblock. But why? Why does that tiny, tiny delay feel so profoundly wrong to us?
Well, the difference is just night and day. A real human chat, it's like a dance. It's fluid. There's a give and take. But with most of the AI we talk to today, that dance becomes this stilted, robotic march. It's the difference between something that feels totally intuitive and something that's just actively frustrating. The holy grail for every engineer in this space is to completely erase the right side of the screen and make every single AI chat feel like the left.
So to actually solve this thing, we first have to figure out what natural even means. We need a benchmark, right? A gold standard for conversation. And believe it or not, scientists have actually found one. And it's measured in fractions of a second.
200 milliseconds. That's it. That is the magic number. I mean, think about that. Researchers looked at 10 different languages, different cultures, and found that our brains are fundamentally hardwired to expect a response within that tiny little window. It's not something you consciously notice. It's a rhythm that's just baked into our social DNA. The second you violate that rhythm, the whole conversation just feels broken. This is the target. This is what AI has to hit.
And look at how these milliseconds translate directly into how we feel. Once you go over 1,000 milliseconds, that's just 1 second, you fall off what engineers call a latency cliff. Your satisfaction doesn't just go down, it absolutely plummets. But here's the really wild part. Sometimes being close to human speed is actually worse than being obviously robotic. Our brain detects that something is almost right, but just off. It's like the uncanny valley of conversation, and it creates this huge sense of unease. The real goal, that human parity level, is under 500 milliseconds. That's where the magic happens, where the line between person and program starts to get really blurry.
Okay, so if the target is under 500 milliseconds, where is all this time disappearing? To find out, we have to basically pop the hood. We need to do a full dissection of the journey our voice takes, a millisecond by millisecond audit, to hunt down the sources of that maddening delay.
Think of it like a relay race, where every single handoff adds a little bit of time. First, your voice has to travel over the network. Then, a system has to figure out that you've stopped talking. After that, your speech gets transcribed into text. That text then goes to the AI's brain, the large language model, to figure out a reply. And finally, that reply gets turned back into audio you can hear. Every single one of these steps adds precious milliseconds, and they all stack up to create that awkward cumulative silence.
And this right here is the absolute key takeaway. The solution isn't just making each individual model a little bit faster. The biggest bottleneck is the whole architecture itself. See, old systems work like a clunky assembly line. One step has to completely finish before the next one can even start. The big breakthrough is something called a fully streaming architecture, where all these steps are happening at the same time, in parallel. It basically collapses the whole timeline from a long line into a single instant. But let's say we fix the latency problem perfectly. There's another sneakier problem lurking in the shadows: the actual quality of the sound itself. There's this ghost in the machine that still haunts so many conversations, especially ones that happen over the old legacy telephone network. And this just illustrates the difference perfectly. Old school phone lines use what's called narrow band audio. It literally strips out all the low and high frequencies from a human voice. It's like looking at a super low-res pixelated image of a voice. It removes all the warmth, all the clarity, and leaves you with that thin, metallic, scratchy sound. Your brain actually has to work harder just to understand it. Compare that to modern wideband audio, which preserves the full, rich, clear sound of a person talking. It's a world of difference.
Right, because these technical problems, the delays, the bad audio, they aren't just numbers on a screen. They have a massive and totally measurable psychological impact on us. They create this powerful friction that fundamentally changes how we perceive the AI we're talking to. Okay, get this, because this is absolutely fascinating. Research shows that when we hear any voice through a bad, low-quality channel, we subconsciously judge the speaker,
doesn't matter if it's a person or an AI, as less credible, less trustworthy, and get this, even less intelligent. Just think about that. A company could have the most brilliant AI on the planet, but if they deliver its voice over a bad phone line, our brains are psychologically primed to think it's dumb.
So this psychological friction, it's not just a vague feeling. It translates directly into real, tangible negative impacts on a company's bottom line. The cost of a bad conversation is very, very real. Let's look at the numbers. When the audio is all garbled, what happens? You're constantly having to say, "Sorry, could you say that again?" Just that alone leads to a 27% increase in the average time it takes to handle a call. For a big company, that is a massive hit to efficiency. Oh, but it gets worse. 42%. Nearly half of customers admit they have just given up and hung up a call immediately because of noise or bad clarity. That is a customer, a sale, or a chance to solve a problem that is just gone, poof, all because of a technical issue. And boom, here's that latency cliff again in black and white. The moment a delay crosses that 1-second threshold, the number of people who just hang up skyrockets by 40%. You combine bad audio with high latency, and you've basically created the perfect recipe for losing customers. So the problem is crystal clear. The stakes are incredibly high. But here's the good news. The solution is being engineered as we speak. Companies are in an all-out sprint to achieve true conversational fluidity, and they have a very clear blueprint for what it's going to take to win. This is it. This is the goal line. These are the non-negotiable targets. You need latency that's consistently under 500 milliseconds to stay below that psychological cliff. You need wideband HD audio to be the default, not the exception, so the AI sounds credible. You need the ability to handle interruptions gracefully, so you can just talk naturally instead of waiting for your turn. And all of it has to be built on that rock-solid foundation of end-to-end streaming. Meeting these targets is what's going to separate the next generation of AI from everything that came before. This whole journey to make AI feel human is really a war being fought on the frontier of milliseconds and hertz. It's this incredible fusion of cognitive science and bleeding-edge engineering. And as this tech gets better and better, it unlocks a future where teams of autonomous agents can collaborate with us and even with each other in perfect, seamless sync. So the real question is, as we close in on that final millisecond, what new possibilities are truly about to be unleashed?